The topic of this lesson is to find vertical asymptotes. We've already talked about horizontal asymptotes, and on a graph, a horizontal asymptote would be like in our exponential functions, where they are close to zero and then they increase. Well, that would be a horizontal asymptote. And for a vertical asymptote, the difference is that in a graph, it means that we are going close to a number and never touching that number but vertically. So there is a vertical imaginary line that we almost never cross. How we find that is, if we look at the curve that I drew, you can see that it's going, and it's going up. And what is that number going up to? It's going up to infinity. So we have a number, and it's going to infinity. And in this lesson, our equations are all rational functions. So in a rational function, that means we have a fraction with the x in the denominator. In this fraction with x in the denominator, we're going to get close to infinity when we're plugging in x's. So let's just check and see what type of x's it takes. So if we take 1 over a big X, so if we want to do a big X, let's try like 1,000. Then 1 over 1,000 would be something about like 0.001. That'd be 1/1000th. So 1/1000th, is that anywhere close to infinity? No, that's the opposite direction of infinity. So plugging in big numbers is not going to get us something close to infinity. It's not going to get us any closer to infinity. So then if we look at our graph, you can pay attention and see that we were plugging in things that were close to the origin. We were plugging in x's close to 0. And if we plug in x's close to 0, 1 divided by 0.01 equals 10. 1 divided by 0.001 equals 1,000. Oh, this one's actually 100 because this one is 1,000. But the point is, the closer this decimal is to 0, because these decimals are just getting tinier and tinier and tinier, we're adding more zeros. And if we're adding more zeros, then we get closer to 0 as the denominator gets closer to 0, the output becomes larger and creates an asymptote. Well, more specifically, creates a vertical asymptote. So whenever you're plugging in things into these rational functions, whenever the denominator gets close to 0, the output's going to become large, and it's going to make an asymptote, a vertical asymptote. So in these questions, we just need to find out, when is the denominator equal to 0? When is this equal to 0? So you take the denominator and set it equal to 0. And in this first question, there's nothing to solve for because it's just the plain x. So x equals 0 cannot be used. The reason why x equals 0 can't be used is because if you look at this graph, let me clear off some of this now. If you look at this graph that I made earlier, as we get closer to 0, we're going to get close and close and close to plugging in 0, but we can't actually plug in 0 because it's going to give infinity, and you can't plug in infinity because that's not a definite answer. If we look at number 2, we're going to take the denominator and set it equal to 0. X minus 2 equals 0. We're going to solve this for x, and when we set it the denominator equal to 0, we're solving for when is this whole thing going to look when we're setting the denominator equal to 0, what we're doing is we're checking for when is this equation, this 2 divided by x minus 2, when is it going to look something like 2 divided by 0? What x, if I plug it in, would make 0 in the denominator? Because if you get 0 in the denominator, it's going to make an asymptote. And you can't plug in for an asymptote. X equals 2 cannot be used. Go to number 5. We're going to take the denominator, and we're going to take the denominator and set it equal to 0. X plus 8 equals 0. That means x equals negative 8 cannot be used. Next one. And that's all there is to it. So the steps are factor the top if you need to, simplify the rational function, which is what we learned in our last lesson, was sometimes you can cancel some things out. So if you can cancel things out, you should do that first. Then you set the denominator equal to 0, and then you solve for x. In Algebra 2, these steps happen a lot more often, but since this is just Algebra 1, the main focus for our class is just, can you do this and solve for the asymptote? Can you set the denominator equal to 0 and solve for what you cannot plug in for x?